Okay, so before we move on, let's take a look. We talked about adding and subtracting with our mixed numbers. What if we mix just whole numbers with mixed numbers? Like, I don't know, 7 plus 3 and 2/5. Well, if I go to add those, if I set them up vertically, remember I leave that fraction out at the end like it's the last digit of the number. Remember when we had decimals, we'd have to fill in zeros if we were going to, if things didn't line up. Similar type of things here. We have to line stuff up. We have our ones. The 7 and the 3 are both in the ones place. Those are lined up. But there's nothing to line up with the 2/5. I can put in a placeholder here. And in math, our placeholder is a 0. But since that's a fraction there, we need a common denominator, which will be 5. So this is going to be 0/5. Did I alter the value of that 7 at all? No, 7 and 0/5 is still just 7. I just put in that 0/5 so I could work with it. So now when I go to add, 0 plus 2 is still just 2/5. 7 plus 3 is 10. It'd work the same way if our fraction were first, like, I don't know, 6 and 1/3 plus 2. It's going to go the same way. I have my 6 and 1/3 on top and 2 on bottom. I need something to fill this place. Now I'm going to use the same denominator as the other fraction, the 3, and just put a 0 over it. Again, 2 and 0/3 is the same value as 2. I'm filling that place. So now 1/3 plus 0/3 is still just 1/3. 6 plus 2 is 8. Good. Now, the reason I was adamant about this, I mean, a lot of you probably look and say, oh, you don't need to add the 0/3, just bring down the 1/3. And that's true. But when we go to subtraction, it's more important to have it there. So we might have something like 9 and 3/4 minus 3. So 9 and 3/4 minus 3. I'll put in that placeholder again. Of course, I'll have the denominator of 4, so the same denominator. Put in the 0. 3/4 minus 0/4? Just 3/4. 9 minus 3 is 6. Now you still might be saying, well, you could still just bring the 3/4 down. But again, always gets a little more complicated. Let's have 7 minus 2 and 5/8. So I'm going to have my 7, my 2 and 5/8. Well, again, I need a placeholder for that 5/8. It's going to be 8, so I'll put in 0/8. As I mentioned, here's where it gets a little trickier. I go to subtract, 0 minus 5 can't be done, so I'm going to have to borrow from the 7. That's a 6. Just like any other borrowing of my fractions, I add my denominator. So 0 plus 8 is now 8/8, and then I can subtract. 8/8 minus 5/8 is 3/8. 6 minus 2 is 4. Now there are probably a ton of shortcuts out there that you've all been taught to do these. If you have one of those that you use and it works, that's fine. Feel free to use them. I'm not going to get into them because I could, off the top of my head, rattle off 4 or 5 different ones. So I'm not going to get into them here. And the same thing, of course, applies if it's just a whole number and a fraction rather than a whole number and a mixed number. If I have 7 minus 2/3, it's 7 minus the 2/3 lines up over here with the fractions. There's no whole number. I could actually fill in 2 place value holders if I want. I could put a 0 in 2/3 if I wanted to. That's not so big. But I do have to have 0/3 here, so that when I go to subtract, I can borrow from the 7, make it a 6, and add 3 there to make it 3/3. 3 minus 2 is 1/3. 6 minus nothing is 6. Yeah. Yes. If you already know it, you just put the 0/3 in, or put the, Instead of writing it as 7, you could write it as 6 3/3. Yes. If you see it coming, yeah. That's one of those shortcuts. But it does work every time. Okay, so our next step is to multiply with our mixed numbers. So let's take a peek at 5 1/4 times 7 1/3. To multiply mixed numbers is actually a really complex, difficult process. In fact, we could go to any four-year university. If you found 10 math majors, I'd be surprised if even one of them could multiply mixed numbers correctly. So how are we going to do it? Well, we're going to cheat. We're going to change them to improper fractions. So remember, the denominator doesn't change. This is going to stay fourths. How many fourths is it going to be? 21. Good. 5 times 4 is 20. Plus 1 is 21. How many thirds over here? 22. Good. 7 times 3 is 22. 7 times 3 is 21. Plus 1 is 22. And now we can cross cancel here. 4 and 22 both divide by 2. 4 divided by 2 will be 2. 22 divided by 2 will be 11. Can I reduce anything else before I multiply? 3 and 21 both divide by 3. 3 divided by 3 is 1. 21 divided by 3 is 7. So now we have 7 times 11 is 77. 2 times 1 is 2. And of course, we'll reduce that down to a mixed number. 77 divided by 2. Well, 2 goes into 7 3 times. That's 6 with 1 left over. Bring down the 7. 2 goes into 7 8 times. That would be 16 with 1 left over. So that's 38 1/2. Any questions on that? We're going to do a couple more examples. Does anybody want to see how we would actually multiply the mixed numbers without changing them? Just for fun? No? Don't want to see it? Okay. It's a pretty lengthy process. Okay, so you're one. I've only, in the years I've taught this, there's only been like 3 or 4 groups that said, no, we don't want to see it. There's always somebody like, I really kind of like to see that. So it's kind of funny. So anyway, let's do another example. Let's take like 4 3/5 times 2 5/8. Tell me what to do. Improper fractions. What's going to go here? 23 over 5. Very good. 4 times 5 is 20, plus 3 is 23. What's going to go over here? 21 over 8. Good. 2 times 8 is 16, plus 5 is 21 over 8. Then what? Cross cancel if we can. Is there anything we can cancel here? Careful. 8 and 24 would be, but 23 is not. So, what's that? Can't cancel anything here, no. So, 23 times 21 is 481, I believe. 43, thank you. Thanks. Little hamster is falling off the wheel at this point of the night. 5 times 8 is 40. And then we have to divide. 483 divided by 40. 40 does not go into 4. 40 goes into 48 once. That's 40 with 8 left over. Bring down the 3. 40 goes into 83 twice. That'd be 80 with 3 left over. So it looks like 12 3/40. What's that? Can't reduce that. No. 40 does not divide by 3. If you can't cross cancel before, you won't be able to reduce afterwards. The only operation that's different is subtraction. Some occasion with addition, but subtraction, sometimes you'll get 2 things where you have odd numerators and you subtract to get an even numerator, and now you can reduce because you have an even denominator. But usually you cannot. Okay, so let's do one more example of that, and then we'll move on to division. So let's do 7 2/3. Actually, do 7 1/3 times 5 1/4. I'm going to try that in your notes. See how you come out. So we change them into mixed numbers. What's this one become? 20 2/3. Good. 7 times 2 is 21, plus 1 is 22. What's this one become? 21 4ths. Good. 5 times 4 is 20, plus 1 is 21. So now we can reduce. What can we cross cancel? 22 and 4. Give me 2 and 11. And as you said, 3 and 21. Give me 1 and 7. So we have 77 over 2. If you're paying attention, I just wrote those numbers in different order. Multiply the same two numbers.
When I crossed off, I thought there was a 1 in front of my 7, so I did 11.6.
Oh, gotcha.
I am still weaker on that.
Did you end up with these two same improper fractions? 22 over 3, 21 over 4?
Yep.
So when you multiplied, did you cross cancel at all or no?
Yes, I did. I did get 11, and then I put the 2 underneath the 21.
Okay.
The 1, and
You reduced the 21 wrong?
there was 3 divided by 3 is 1. 21 divided by 3 is 6. Yeah, I got 20. No, I didn't get it right. I got 24 over 4.
Okay, that's where your difference is then.
Okay.
Yep. So you had 8 there instead of 7
Yep.
when you reduce. That'll do it. When we divide, just like when we were doing our regular fractions, we turned it into a reciprocal and multiplied. So with mixed numbers, it makes sense that when we divide, we're going to turn them into reciprocals and multiply. So our first step is going to be just like with our multiplying of mixed numbers, we're going to have to turn them into improper fractions. So what's this one going to become? 22 over 3. What's this one going to become? 2 times 4 is 8 plus 3, 11 over 4. Is this multiplication now? No, still division. Can I cross cancel the 22 and the 4? No, because it's still division. I can only cross cancel once it's multiplication. Get back here. So now we have to do the reciprocals. Yes. And I know where you're going with that. Now that we've done the reciprocal and now that it's multiplication, can we cross cancel? Yes, we can. We can cross cancel 22 and 11, both divided by 11 to give me 1 and 2. So 2 times 4 is 8. 2 times 1 is 3. This one we don't have to divide out the long way. 3 goes into 8 twice, with 2 left over. Yeah, 38 and a half. Yeah. Yeah. Okay, let's do another division. Let's do 4 1/2 divided by, let's see here, 1 1/5. I'll let you guys try this one. What the heck? So we're going to change them into improper fractions. 4 1/2 becomes 9 1/2, 9 over 2. 1 1/5, 6 over 5. Can I cancel the 2 and 6? No, I can't. Perfect. The 9 over 2 doesn't change, but it's going to become times 5 over 6. Now we can cross cancel. What will cancel? 9 and 6 will give me 3 and 2. So 3 times 5 is 15. 2 times 2 is 4. 4 goes into 15 3 times with 3 left over. How are we doing? Good? Oh, gotcha. Well, you just ended up with 45 over 12, and then you can reduce from there. Just a little extra work is all.
So if you do forget to cross cancel, you're still eventually going to.
Yep, if I didn't cross cancel here, if I had 9 over 2 times 5 over 6. 9 times 5 is 45. 2 times 6 is 12. I could reduce it here, or I can do the mixed number. If I do the mixed number, 12 goes into 45 3 times with 9 left over. Both the 9 and the 12 can divide by 3. 3/4. I gotta remember the whole number of 3. Or I could have reduced here and said, hey, both of those divide by 3. That gives me 15 over 4. And I'm right back to here. It's 3 3/4. So I will get there. It's just a few extra steps is all. And you have to work with bigger numbers. There's a magic button on your calculator. Many of your calculators at least. It looks like this. ABC. My calculator on screen here doesn't have it. Most of your graphing calculators do not. That's the one big weakness about graphing calculators. They don't do fractions well. Your little $12 or $13 TI-30s do them very well. There are a couple of apps for your phone. So I had them written down here. I'll find it, I'm sure. Maybe. There we go. Nope, that's not it. Anyway, I know there's Mathtastic, or not, yeah, Calctastic, and then Mathway are the two that do it. So if you're going to be using your phone as a calculator, those are two apps that you can download for your phone that do those two, the fraction calculations. On your TI calculator or on your Casio calculator, you may have an ABC key that does this. So if you have the ABC key, if you wanted to enter 2/3, you would type in 2, press the ABC key, and then 3, and hit equals. And it will display either like this, or, depending on your calculator, it might display like that, 2/3. If you want to enter 5 and 3/8, you press 5, the ABC key, 3, the ABC key again, and then 8, and it'll display that. So if you want to add, subtract, multiply, divide fractions or mix numbers, that key is your way to do it. Now, I'm not going to take any time in class to do examples, but you can go back through any of the examples we've done so far and try to enter them and see if they come out the same. If not, let me know and I'll be happy to sit down and try to figure out how your calculator works.
So that's just if we use calculator and calculator.
Yeah, if you want to use the calculator to do the calculations. The only reason I'm showing you that is at some point we are going to step up to using these fractions for some things like this. So solving this equation is no different. I mean, this is exactly the same as solving an equation like 2x minus 5 equals 11. We're going to add and then we're going to divide. But the presence of the fractions, 1 makes it look scarier, and 2 makes the calculations a lot longer. And we're still going to solve this by adding 2.5. So over here, all that's left is 3/4 x. Over here, 5 and 7/8 plus 2.5. Well, if you did the common denominators and add that out, you're going to come up with 8 and 3/8 is your result there. And then you have to divide by the 3/4. So 3/4 x divided by 3/4 is x. Now we have to do our 8 and 3/8 divided by 3/4. So that's going to end up being 67/8 times 4/3 Cross cancel the 8 and the 4. Get 67 over 6, so it's 11 and 1/6. So when we get to doing stuff like that, at that point I'm okay with you going ahead and punching it in the calculator and letting it spit out the fractions, because getting bogged down in the calculation, you forget what you were doing back with the equation. I still do the calculations by hand just for fun. That's what type of weirdo I am. So anyway, our next step with our fractions are fractions that look something like this. This is an order of operations problem. That's all it is. The fraction bar is telling us we're going to have to divide something, but it's also an enclosing symbol. It's telling us we have to do everything on top, then do everything on bottom, and then do the division. So on top we have 2/3 plus 5/8. So 2/3 plus 5/8. My common denominator will be 24. This is going to be 16, and this will be 15. A question so far, and I'm kind of flying through this. So 16 plus 15 is 31 over 24. I could break that down into 1 7/24, but right now I don't want to. The reason I don't want to is, remember, this fraction bar means divide. I'm going to have to divide that by something. And to divide, I need it as an improper fraction anyway. So why break it down when I know I'm going to have to just turn it back? So 1/2 times 4/5. I can cross cancel the 1 and 4. Give me 1 and 2. 1 times 2 is 2. 1 times 5 is 5. That's just 2/5. This thing right here tends to confuse a lot of people. That is just a different notation from what we're used to seeing. But that is simply 31/24 divided by 2/5. So now how do we handle it once we have it like this? Yeah, 31/24 stays the same. Multiply by the reciprocal of 2/5 is 5 over 2. 31 times 5 is 155. 24 times 2 is 48, which is 3 and 11/48. Any questions? So have you guys try one of those? Two and a half times 1 4/5 divided by 1 1/3 plus. Oh, we'll make this 7/8. Go ahead and try that in your notes. So we'll take a little bit of a shortcut here, but on top, we're going to change these into improper fractions. 2 and a half becomes how many halves? 5 over 2, right? 5 halves. 1 4/5 becomes 9/5. The 5s will cross cancel to give me 1 and 1. So 1 times 9 is 9. 2 times 1 is 2. So we get 9 over 2 on top. On bottom, 1 1/3 plus 7/8. Well, I'm going to make this 24ths. So that'll be 1 8/24 plus 21/24, which is going to be 29/24, 1 5/24. So keep the 5/24 and carry the 1. So we got 2 5/24 on bottom. So we still have to divide now. 9 halves divided by 2 and 5 24ths. The 2 and 5 24ths, 2 times 24 is 48, plus 5 is 53 24ths. Take the reciprocal, 24 over 53. We can reduce. 2 and 24 divided by 2, give me 12 and 1. 9 and 53, they look like they should, but they don't. 9 times 12 is 108. 1 times 53 is 53. That is 2 and 2 53rds. Anybody get that? One couple.
I like the bottom in
This year? Well, you got the 1 and 5 24ths, or the 29 24ths. You still got to make sure you combine the 1 with it. That's what you forgot. Yeah. Here. So that if you didn't do that, you would have just got 216 over 106, which would become 2 and 4 over 106, which still reduces to 2 over 53.
When I did it, alright, I did the reciprocal, I did 5 over 2 times 5 over 9. How did I do that?
5 over 2.
Because it was 5 over 2 divided by 9.
Over here? That's times though. So it would have been 45 over 10 here. You flipped the wrong one. Yeah. That'll do it. Okay, it looks at this point what we need is practice. There is a new quiz due tomorrow, which is Friday at 11:59 p.m. There's a new homework due for next Tuesday. And remember, there will be a Unit 2 test 1 week from tonight. So next week, Thursday, Unit 2 test.